Hey, Keith.
Does Jake get excused like for all these things?
Those all medical, yeah.
I need to like get surgery or something.
I know where you're at.
Here we go.
So do you show the Pitha or do you just do it?
No, I just know, like, Alexis will be able to look at them now since she's missed the 3 days. So whoever's absent can grab them from home.
Are you
Thanks,
recording
dear.
this
Yep, we are recording.
right now?
Right now.
You don't have your thing on.
Oh, I don't have my thing on.
class.
Yeah, got my little. They probably will. There we go. Okay. Okay, arc length. We're going to take the intuitive approach until you can come up with a formula for me for arc length.
Oh.
So, let's go back to our circle with our 4-inch radius. This circle.
This is where it's the 4. That's what I thought.
I just randomly picked a number here, and we're going to go with 4. If I gave you an angle measure of 1 radian, could you tell me this arc length? How much distance is there from the end point to the end point? 4 inches. So the arc length here, and they use S for arc length. S for arc length. I don't like using S. I have to take my time, otherwise they look like 5s. But the S would be.
See, I have the opposite problem. I guess.
No. The S, the arc length, would be 4 inches, because you know what a radian means now. The radian is how many radius lengths around.
Wait, what's S?
Arc length. It's the letter that the book uses for arc length.
What's arc length?
How long this distance is on the arc of the circle.
Where's the Lexi?
The length of the arc.
So is that a 1?
1 radian.
Why would it be a...
Oh, well, we can explain yesterday to you. Okay?
I'm yawning.
If it was
I forgot that she wasn't here. I'm sorry.
2.5 radians is my angle, could you tell me this arc length? Or could you figure it out if you knew the radius was still that 4 inches?
Did you put 2.5?
I will. How do I figure it out?
2.5 times 4.
Yeah, I have to multiply it. This is telling me I've got 2.5 radius lengths around here. So 1 is 4 inches, 2 is 8 inches, and then I need a half of a 1. So the S would be 2.5 multiplied by the radius, and we get 10 inches.
Come on, Short, give us a
So,
challenge.
could you give me a formula for arc length? What's the formula for arc length? S equals,
4 times
R.
well, if this was R,
I
a
mean,
generic radius, if that was
times radian.
radius times radians. You agree with that? The radius length times the radian angle measure. So, she said radius, I'm going to write it in words, times by radians. So the symbols for that are theta. So, what's crucial to getting these problems right is that this theta must be in radians. It would make absolutely no sense if I had said this was 50 degrees here, 50 degrees, would that make any sense to say, oh, it's 50 times 4? No. You have to have it in radians, because that radians indicates how many lengths of the radius. So, if you want the picture to go with it, there's your R, there's your theta, and here's your S. But the big thing to remember is that theta must be in radians. not degrees. You have to convert it if I give you a degree. So really what makes today challenging is the algebra in solving some of these.
Oh, because radian's not for me, radian.
Alright, so let me start you out.
Ooh, we're already on examples.
We're already to examples. We've got our formula. You came up with it nicely.
Mars.
Okay, let's take this point. We're going to rotate it around the circle. We're going to rotate it 218 degrees. And this radius, just going to rotate to make an angle. Taking that point and traveling it around there and stopping here. I'll tell you this radius was 12.1 inches. Can you tell me the distance that point traveled? So that distance traveled is arc length. You agree with that?
Yep.
The distance traveled is going to be the S value, the arc length. How much distance around the circle? I only need to know two things, the radius and the radians. What's the radius?
12.1.
12.1. Do I know the radians? No. So, what do I have to do to this 218 degrees? Divide by 180. And then times by pi. Yep. So, I don't know if we can be exact on this one or not.
Wait, would I only understand this if I was here for the notes yesterday?
Correct. You would not have understood this part right here.
Okay.
So, grabbing your calculators. $12.1 times 218 divided by 180 multiplying by pi.
46 points.
So about 46.0. If I go 3 sig figs, they do sig figs here too. Again, I don't mark anything wrong for sig figs. 46.0 inches.
Is that, did you,
So I did exactly what I wrote on my paper.
I already ate it. Oh, so I ate it after.
Okay, number 2.
I keep forgetting to eat. That's dangerous. That's like forgetting to breathe.
I eat every hour.
4.2 inches. 6 inches.
Every hour on the hour.
Looking for the angle theta in radians. So what 2 pieces of information do I know?
You actually know the S.
I actually know the S,
Is that 4.2?
the theta. I know the S is 6. What else do I know?
The radius.
The radius is 4.2. I don't know the angle measure. But if I know 2 out of the 3 parts in a formula, algebra lets us solve for the 3rd part.
Pretty easy.
There's the formula for arc length. Substituting in, I know the S is 6, 4.2 times theta, divide by 4.2. What is 6 divided by 4.2?
I got a decimal, so I just put it into a fraction.
And what'd you get for a fraction?
10/7.
10/7 radians. And there's no symbol for radians. Good on that one?
He's got feelings. You don't want to get your food.
And then No, and then when my mom goes, Matt, you need to eat, I told her no. Doesn't matter.
No, basically a girl. Like Alyssa at lunchtime. I don't know why I'm crying. Just with a giant smile on her face. Just a giant smile on her face with tears like running down her face. So emotional. She's smiling and crying at the same time. I was like, that's my life. Alyssa.
That's awesome.
And we were like laughing at it, and she was just laughing at herself, like, I don't know why I'm crying right now. I don't know, it's kind of emotional. Like, oh my
Starts
god,
crying
this
right
guy,
now.
people think we're crazy, psychotic, like, she's like smiling and crying.
Okay, almost the same problem.
Because everyone hears our conversation now.
Oh, crap. Great.
Wait, quick question.
Still looking for the angle, but this time I want the angle in degrees. So how does that change this problem?
I'm really confused on where you...
Where I what?
Where is everything going?
Okay. So I'm showing this point rotating this direction, so it's traveling along here.
Yeah.
So what is this 35.76 I'm giving you?
Alright.
That is the arc length. That's how far this point traveled. That is the S.
So it's just like the last one.
This is
Yeah, but we gotta convert it to degrees after.
the R. I'm still trying to solve for theta, but when I finish, I want to be in degrees. Does the formula change for arc length? No, formulas can't change. Still, S equals R theta.
But why is it on the inside of the...
Oh, I got it in the wrong spot. Good call.
That's why I was on...
Good call. Theta belongs over there. I wanted the angle of the rotation.
That would have been confusing.
Yeah, that was my bad. I want that angle out here,
Wait, so what is the arrow that's going up?
showing the direction of the rotation.
Is that what we're looking
Wow, that's big.
I already know how far it traveled. I don't know the angle measure that it went through.
Wait, we want the outside one, not?
Yes, I want the part of the rotation.
for? I don't get it. So you want the...
It's like me. Watch my arm. I'm here.
Theta.
Watch my arm rotate.
Yeah.
Oh, I want to know the angle here. How far did it go from here over to there?
Over the.
What's the sign for that? What is that?
Theta, angle measure. Okay, well,
Close the door on us.
all right. So, what can I substitute in for?
S and the R.
S is the 35.76. The R is the 7.35, timesing by theta. So I can solve for theta algebraically by dividing. So theta equals something I can't do in my head. Will it go into a fraction? If it doesn't, we'll go decimals.
It does, but
Well,
it's-
actually, these are decimals. Let's go decimals.
It doesn't go into a very good fraction.
Okay. So let's go decimal. What is it? 8.7? Okay, that's my theta value. What are the units on that?
Second.
That would be radians. Remember, it's radius times radians. I just found the radians. I wish they had a symbol for radians. It would make more sense. Okay? I don't know.
Can we make our own?
Nope. Well, we could put a little r, I guess, if we wanted to say that. But that's radian. Then it looks like radius. Yeah, okay, won't go there. Okay? I wanted the answer in degrees, but you learned this skill yesterday. How do you get from radians to degrees? Out of radians into degrees.
You divide by pi and multiply by 180.
So I'll take the 4.87, divide by pi, multiply by 180, and we'll go decimal. So actually do all that. How many degrees was that?
279.03.
Degrees. My estimate wasn't too bad.
Good job, extra.
Okay, number 4.
We are not good with Sig Figs in that problem.
Did that one.
How many examples are there?
I have
How big is it?
6. Let's see. Oh, I didn't do any exact ones. I got to do an exact one because you got some exact stuff. I wonder if you do have any exact. I'm not. I've crossed it off. I'm going to go with no.
Why you gotta be like that?
Let's see. Oh, find the radius.
Wait, so on the speed, it was not because you switch it with the speed there, technically?
Nope, that's the angle. That's the 218 degrees, and this is the radius length here. That 12.1 is this distance here. Huh?
Why is that one on that side then?
Because the same thing as this. The 218 is on the outside. This, I'm looking for this. Well, I could have put it in here. But that's still the radius. That's this distance. Doesn't matter whether I put it above or below. Okay, next one.
Can you move it up?
Oh, yep, I can. Radius. We're going to go.
Guys are gay.
Okay, the little chit-chat and off-topic conversations over here need to stop. It's distracting for everybody. So we've got a 168-degree rotation. The distance covered by the point was 28.4 centimeters. Can you find the radius? So, what two pieces of information did I give you?
You gave us the S.
I gave you the S. And I like to call this almost theta, because theta technically is radians.
Okay, almost there.
So I like to call it almost theta.
A little worm,
Yeah, a little worm.
a little inchworm going on.
Almost theta. So we're still going to use the S equals R theta problem.
What other formula do we have?
That's the only one we've got now. Well, we're going to get more as we go through this chapter.
168 degrees.
Yes, it does.
And then worm theta.
Yes. I like to identify what's given, and that's not quite the theta that I need for my formula. Okay, so
Convert the centimeters?
do we need to convert the centimeter one? Good question. Do we need to convert this S?
Probably the inches.
No.
No. Do we need to convert the 168? Yes, that we do need to convert. So, do we want to do it off to the side or in the problem? It doesn't matter to me. I'm going to do it off to the side. To get theta, I'm going to take my 168 degrees and do what? Out of degrees into radians.
Divide by 180 and multiply by pi.
Divide by 180,
That's what I was trying to say.
multiply by pi. 3 sig figs. What is theta?
At 2.93.
2.93. Sounds good. So now we're ready. I've got S is 28.4. The radius I'm looking for. We just found the theta to be 2.93. Simple algebra step to solve for the radius. What was the radius of our circle?
9.69.
7 point.
Oh, we got some confusion there, disagreement.
9.69.
9 point
69.
Oh, I put
centimeters. Any questions on that one?
Can you leave it up for 2 more seconds?
Yep. And we've got one more thing to cover.
Like so,
Cannot.
so that's the answer.
That's the answer. Our formula only is radius times radians. I have to have radians to use the formula. It's the only time the formula works. Okay. If I had a globe, what do you call the lines that go up and down on the globe? Yeah, which ones are the ones that go up and down? Longitude or latitude? Longitude and latitude are the ladders. Is that how you remember that?
Yep.
That's how I remember that. Okay. So, we are going to look at cities on the earth that are on the same longitude line. So they're going to be on the same longitude line. All right? And we can find distance between cities on the same longitude line because it's just finding the arc length on the surface of the earth. You agree with that?
Okay, yeah.
If they're on the same longitude line, it's just the arc length of a circle.
I'm spelling what you're saying.
Okay, so, all right, so
I'm ready.
distance,
Is this an another example.
This is the directions first. Distance
Up an example?
between
No.
two cities on the same longitude line. Okay, so I've sliced the Earth right down a longitude line. I'm looking at the circle, okay, cross section. What longitude line is this?
The equator.
And what degree measure does it have?
0.
0 degrees.
That's not a longitude line.
Well, it's the position of the, and then, yeah, it is. Oh, is it, oh, latitude, you're right, it is a latitude. But they're on the same, well, yeah, we're going to use latitude, yes, that's a latitude, thank you. So if I go up, they're on the same longitude line, but then its position up is a latitude, how far above and below. Okay, so whatever longitude line this is, I don't know what it is, but the latitude is 0. Thank you for correcting me. When I go above the equator, that's a northern latitude, so they'll give like an N in front of it, like north, what does that look like, 30 degrees maybe?
Sure.
Estimating. If I'm below the equator, how do they give that latitude?
So.
South, and then however much. Like south, what's that about, 60. 65. Good. So when they give you north, that means you're above the equator. South, you're below the equator by that much. So this angle in here is the 30 degrees. This one down here would be the 65 degrees.
You don't do like negative 65, right?
Nope, nope, we don't do that. Latitudes aren't with negatives because they've got the S to indicate below. Okay, so if I wanted the distance between this city and this city, I can use the arc length formula if I know what else. I've got an angle measure. What else do I need to know?
Radius.
The radius of the Earth. Okay, they won't tell you when you get to the problems what to use. I'm going to tell you right now, and you're expected to remember it. They use 6,400 kilometers as the radius of the Earth, km. So we still use the same arc length formula, S equals R times theta, but what's R going to be every single time we're on the Earth? 6,400. And my angle still has to be in radians. So even though latitudes are given in degrees, we're going to have to do a little converting. Are you ready for one of these? I guess. I have two examples left.
Oh, okay, never mind.
All right, we have Farmersville, California.
Wow.
Has a latitude of 36 degrees north. And Pentacon, British Columbia. Has a latitude of 49 degrees north.
Okay, so now that this is latitude, when you wrote down...
But they're on the same longitude line. And go ahead with your question.
I think that answers it.
Okay.
I'm not sure.
All right. So they're on the, I can connect them and travel along a longitude line. So I've got the arc of a circle going on.
Wait, which one is latitude and which one is longitude?
Latitude is this way,
Okay.
and then longitude is this way, running.
Longitude doesn't have
Yes. So they're on the same up and down line.
That's the trick.
So don't draw this picture because it'll be a little bit more confusing. Don't draw this one. Okay. So, don't draw this one. Here's my equator. Okay, if I go up 36 degrees, don't draw this picture. This latitude line, see the circle there? Don't draw this picture, I've said it 4 times. That's up 36 degrees. That's where California is. And if I go up 49 degrees, I'm on this circle up here, just trying to show you a little bit here. I want the distance between these 2 towns. So you can see the longitude lines are going around this way like the ladder. The angle's created back here at the center of the Earth. So we don't want to have all that confusion going on. So all we draw is the cross section. Now you can draw. Here's the 0. I always draw in the 0. So I want a line up 36 degrees. So I want to make a 36-degree angle. And that will represent, I'll go F for Farmersville, California. That 36 degrees came from the equator up. 36 degrees. Penticton, British Columbia is 49 degrees north of the equator. So I start at the equator. This time I'm going to go up 49 degrees. Kind of exaggerating things a little bit here, but that will be Penticton, British Columbia. That big rotation from the equator up is 49 degrees. I'd like to know how far apart these 2 towns are right here, because they're on the same longitude line on the globe. So what am I looking for? S, the arc length. I would like to know S. What do I know? The radius of the Earth is 6,400. That is my R. What else do I know about this piece of pie here, I guess?
The inside angle is 13 degrees.
Would be 49 minus 36.
It would be 49 minus. I only want the angle between these 2 towns. I want this angle here. And how do I get that angle? That theta in there, it's almost theta. Almost theta. How'd you get it?
49 minus 36.
49 minus 36. So the angle between the 2 towns is 13 degrees. So now I'd like to kick that into theta. How do I get theta from almost theta? What do you want me to do?
Divide by
No.
180.
Divide by 180 and multiply by pi. Well, I could do that all in the problem too. It doesn't matter whether you do it off to the side or in the problem. What'd you get? 0.23 radians. That sounds about right. So now we go into our S equals our theta problem. We know the radius is 6,400 multiplied by your 0.23. Or you could have done that 13 pi over 180 in that spot too. It doesn't matter. It might save you a little bit of work. How far apart are they to 2 sig figs? 1,500?
Yep.
Nice. Yeah, that's it for that one. I have one more. Number 6. About that much. Okay, I've got a pulley. I'm not going to write all the words. So I've got a pulley that has some string wrapped around it, and then it has a weight hanging off of it. All right. We are going to turn the crank 72.5 degrees. Turn crank 72.5 degrees. The weight rises up 14.3 centimeters. Can you find the radius of the pulley? Okay, and what's the hard part about story problems is, boy, they gave me these numbers, but what do they represent? What letters in my formula did they just give me? So the pulley, the weight stays here. I'm going to turn a handle here, and it's going to start winding the rope around the pulley. And as the rope winds around, the weight goes up in the air. Got a visual on that?
Yeah.
So the end of this string is going to, this point is going to end up about up here after I turn it 72.5 degrees. And this weight will have gone up in the air 14.3 centimeters. Where would I put that 14.3 on my picture? It is the arc length. It's the rope that's wrapping around the pulley. That's how much rope wrapped around to get that to go up that high. So this right here is 14.3 centimeters. That is your S. And the 72.5 is what? Almost theta. So, if we go into our formula, the S is 14.3. The radius, let's do the work right in here this time. Oh, this would have been a good one to do it off to the side. I've got 72.5 degrees. What do I got to do with that to get theta?
Divide by 180 times pi.
Divide by 180
I got 1.26.
and multiply by pi. So you got 1.26 there. So you still have to do all the work. R times 1.26. After you divide,
I got 11.35. 3.6.
oh yeah, 3 sig figs.
Whoa. Going for the jugular.
Okay, I am done. Let's see. It is 3-2, page 119. 2 through 12 even. 13 to 17 all. 19 to 25 odd. Oh, I really like to mix it up today. And 26.